advantage of using Julia and Genie is that you get scaling out of the box. So Julia really has very good performance, and it has built into the language all the capabilities that allow you to do distributed and parallel computing. So Julia itself makes it very simple to run it across a cluster of computers. So scaling is not an issue with Julia and with Genie applications.
Join us as we unravel the journey of Adrian, CEO of Genie Frameworks. Delving into the world of Julia, from the evolution of a web designer to founding Genie, Adrian showcases the benefits of using Julia for web development and the challenges in carving a niche area against languages like Python. Discover Genie's strategy of blending open source with a business to create sustainable ecosystem while exploring future prospects, enterprise features, and AI integration. Welcome to Inspiring Computing. This podcast is where computing meets the real world. Inspiring Computing aims to trigger your curiosity by talking to proficient and advanced MATLAB, Python, and Julia users who use these tools to deepen their understanding of the world around them by simulating it, exploring trade-offs, and gaining insights that help their companies add more value. In addition to proficient users, we will be talking to product marketing, toolbox authors, package developers, and library maintainers to see what drives their development and what issues they're solving for others to benefit from. Welcome, Adrian.
Thanks for inviting me, Garrett. Nice to be here. Thanks.
Yeah, so I met you in person in Barcelona at a Julia meetup, and I was pleasantly surprised of you being the CEO and co-founder of Genie. You're a book author, and you've got this super cool journey that I'd like to dig into. But before we get into that, can you maybe tell me a little bit about yourself, and how is it that somebody coming out of Bucharest, living in Liverpool, Amsterdam, Washington, Bristol, and now based in Barcelona, tell me a little bit about that journey.
Yeah, sure, definitely. So yeah, I'm Adrian, actually pronounced Adrian Sălceanu. This is the question that I get all the time. What's your name? It's Sălceanu. It's a Romanian name. And I'm a software developer, currently living in Spain, just outside Barcelona, with my family and with our dog. We've been here for the last 10 years. And yeah, everything, like my professional career started in around 2000 when I got my first job, which was actually as a web designer. I was at the university, and a colleague of a colleague was building a company. He was recruiting to start creating and selling website. So back then in Bucharest, basically, we were all using dial-up. It was very early days of the internet. The networks were being pulled through the city. Companies didn't have any kind of websites. There was no email. It was just, Yahoo and stuff like that. So I just tried it on a whim, and I began designing their websites in Photoshop. And then at work there, I met a colleague. So we were a team of two. I was a designer, and I worked with another guy. He was a developer. And he actually he came from a difficult background. He barely finished his high school during night classes, and he was like a security guard. And he learned to code on his own, which it was very difficult also back then because there were no blogs there. You really had to, encyclopedias would be on CDs. Yeah, he would read the docs and all that, and he learned PHP, and he got the job. And it really opened my mind that, okay, this is possible. You can learn how to code on yourself. And this kind of common knowledge these days, people ask, you have to be self-taught, do you need a diploma? But back then, people didn't have this kind of concept of just learning the skills and getting onto a job on your own. It was a true inspiration for me. And I started to learn bit by bit. So from design, I started to cut the Photoshop into slices and HTML, and then created a bit of JavaScript. And took it from there, and then moved on to PHP, MySQL. And from there, the career kind of kick-started. I left the company to get my first job as a web developer with PHP, and keep learning, keep growing, and moving on. Then I got degrees in computer science because I also wanted to have this side cover. And that's how it started, and that's how it grew. Most of my jobs were remote. For example, with the companies in the UK, I wasn't actually physically there. I worked for them from Bucharest for a while. Then I moved over to Amsterdam to work for a startup there. So that's where I was physically present. And then from Amsterdam, I've had a short stint in the US with the first startup that I co-founded with some friends. And then we decided to come over to Barcelona and continued working remotely for another company in the UK. And then finally created Genie here in Barcelona.
So it's an inspirational journey that you've gone through. But you mentioned Genie. So for those who do not know what Genie is, can you maybe tell me what exactly is Genie?
Sure, Genie is a web framework that is inspired by Ruby on Rails, for example, or Laravel or Django to some degree. It's a complete web framework that allows for the creation of complex web applications and web API. But it's for a programming language which is called Julia, that maybe not everybody heard about. It's not as well known as Ruby or PHP or Python. Yeah.
So may I ask, why did you create it in Julia? So why Julia?
Because Julia it's a very powerful and very interesting programming language, which has been growing a lot in the less than 5-6 years since it reached version 1. But it's still not hit the level of popularity that it should deserve. Julia is an open source programming language, which was created by a team at MIT. And they really tried to create a new programming language that was leveraging all the progress in compiler technology, all the advances that have been made in the recent years. So fundamentally, something that's completely different from, say, Python or Ruby. It's a language which is optimized for parallel computing, for working with a large level of computations, for distributed programming, async. It has very good performance, but also it looked back and it tried to take all the good features of the programming languages that people love. So it tried to take the good parts of syntax from Ruby, from Python, from Perl, from Lisp. So it's a mix of easy to learn syntax, code that is easy to read and write, but that uses some very intelligent and smart compiler tricks to make the code very performant.
Yeah, so when you talk about that, often when the programming language Julia gets called out, typically people think of mathematical computations, right? So if their math is applied, then Julia is a potentially good fit. But you created a web framework, right? So people don't think of Julia, oh, this is a web framework. How did you come to this conclusion? Or how valid is this?
Yes. So I discovered Julia because I needed a programming language like Julia. I guess if you're doing web development for long enough in a professional setting, let's say, sooner or later, you're going to run into some performance issues. I've been developing with Ruby on Rails, and yeah, at some point, I've had some severe performance issues with an app that we developed. Then years later, I went back to PHP again. When developing a pretty successful application, we ran into scaling and performance issues. So I ended up like the Julia creators wondering if wasn't there any kind of progress in this field that would allow for a new programming language that's as easy as Ruby and as dynamic as PHP, but that is a lot more performant. Well, I wouldn't have to explain to my clients and my bosses why our website is so slow. And yeah, actually, I started to look around and I found Julia, this was the Julia manifesto. Like they wanted to be something that was as dynamic and as easy as these languages, but had the performance that it needed. However, at that point, Julia was very new, very young. I think it was around version 0.4 or 5. And really their package ecosystem was very light and there was no proper web framework that would allow for quick development as I was used to. So then I undertook this task upon myself and I started to code Genie. It was a few years of work, but it was a very pleasant journey until we had version 1 of Genie.
So tell me a little bit more about this Genie. So is Genie like what you say, a framework, but is this like backend, front end? How should I think of it?
It's everything in a sense. It runs on the server, it runs on the backend, most of it, and it generates the UI for you as HTML, but it makes it really easy to write backend code that generates high performance HTML, let's say. So that would be the core. You can either create maybe web APIs with it, or you can create websites, or you can create web apps. You can connect to databases. It's really very similar to Django, let's say, for people that are using Python or Ruby on Rails. However, Genie now is more than just the web framework. It's really more of an ecosystem of packages that allow you to mix and match different types of different features, basically, and add the features that you want to your application. So we're talking, for example, about authentication. Maybe you need that. So you can just install Genie authentication package. Or if you want to do caching, you can install a caching package. We also have a very powerful package for building reactive UIs. So you can add that. And that makes it really easy to create real-time responsive user interfaces, plotting libraries, and so on.
So we got to unpack that. There's a couple of things that we need to unpack with that. If you think of Django in the Python world, typically there's a base Django, and then indeed there's plugins, so the ecosystem works. So if I understand you correctly, you're saying, yeah, Genie also has equivalents, but this is all for free, and they're all based off Julia. And your premise is not like other web frameworks where the authentication is always sometimes a paid service hidden behind it. You're offering all of these things, and you build these additional packages to enable people to become more productive. But tell me a little bit more about the additional ecosystem. I'm curious about what other things have you got there? So like the reactive front end, you mentioned this is easy, but it's not easy. There's entire profession around this. And it can be very confusing. Can you maybe walk me through a hello world, how I'd create a route and how would that end up rendering on an HTML side with maybe a widget? And why would a person coming from a mathematical background even care about all of this?
So to give it a bit of a background of how things evolved, I came into the Julia world with the mindset of a web developer. So I was thinking, okay, I'm a professional that wants to create websites, and I assume that everybody knows how a website is being built if you come from Ruby or from PHP or JavaScript or whatever. But then after Genie was out, I was the main user and probably a few people for the first couple of years. Julia users started to ask about it, and they wanted to create websites and web apps themselves. But because they were not web developers, we quickly discovered that they do not have the concepts to understand how things should be done and what everything means. I was proudly saying that Genies are an MVC web framework, and people were like, yeah, what's an MVC? I'm like, okay, I need to scale it down a bit. This is not right for my audience. And then the nice thing when you do open source is that you continuously get feedback from people, and they guide you and they tell you what they need. So the first very useful feedback that I got was that, okay, Adrian, this is way too difficult for us. We are scientists, we are researchers, we like to work with data, we build libraries, we build models. We don't want to touch JavaScript. We don't like HTML, and CSS is too complicated. Can you make it really easy for us to create a simple data dashboard where I can put my variables, I can take some inputs from the users, I can plot something and just make it all real time and dynamic. That's where the idea came of building Steeple, which is the UI library for Genie, that it runs on top of Genie of the web server and all the infrastructure that's provided, which is a low-code library for Julia. So basically, you don't need to write any kind of web code. You don't need to write HTML, JavaScript, CSS. You just write Julia code. So it has this kind of declarative API or interface where you can go into Julia code and you can say, okay, put a slider here and bind it to this variable, and maybe turn this into a dropdown and here put a plot. And then everything is being built with Julia code. So you just need to learn maybe 40 functions or whatever is being provided by the package. And then the library takes care of everything.
So just for my understanding, so stipple.jl, this is also something you built. So it's not someone else's work. This is a direct response of someone saying, this is just too complicated. MVC, I don't know what that is, and I'm not touching HTML, and I'm not using your tools until you hide that away from me. Is that it?
That's true, exactly. So then Steeple is a package which exposes programming languages, say high-level Julia DSL, to easily build web apps, which gives you over 60 widgets and UI components that you can just use in your Julia code to build a reactive app, or they work very easily.
Okay, so let me see if I get this straight. So is that an equivalence in the Python world? It's not quite like Django, because the Django world has got templating and it's not a Ninja or something like that. Is this kind of a Streamlit? Would that be
exactly
to that? So Stipple is like a Streamlit equivalent.
Yeah.
But if I understand correctly, Genie itself, maybe it's like Django or a Fast API, where you can create your own API per se, and that's a necessary foundational block that you need to build on top of it. Is that a good analogy?
Exactly. It's basically like Streamlit on top of Django, which may sound strange, but it's actually a really good thing. Because one of the issues, for example, with Streamlit is that it's very light.
Yeah.
It's good for prototyping, but it's very difficult to convert into a production application. Say you want to build a UI, but you also want to have an API in your backend, and you want to connect to the databases, and you basically want to take your initial prototype to a full-scale production application. So then you need something like Django in the backend. So that's why when we combine something like Genie with a layer which allows you to build the reactive APIs, basically you get all the power of a full stack framework that gives you all the features you need to start really light and easy, but then you can add all the features that you want in order to deploy an application in production.
There's another component in the production side is maybe the database, right? Connecting to a database or a group of databases. Again, I guess Julia is not known for connecting to databases. So what backends databases do you support? All of them? Are there packages? Did you develop it? Tell me a little bit more what that ecosystem looks like from a Julia perspective.
Sure. Yeah, so indeed, relational databases are not very used in the Julia ecosystem. People usually prefer CSV files, and they like to move data in different ways, usually working with files. But there is support for the most important databases in the Julia ecosystem. So we're talking MySQL, Postgres, SQLite, and Genie provides an ORM layer, it's a set of libraries that let you interact with databases without having to write SQL. So again, we try to make it very simple for our users to not have to work directly with the database, but give them a set of libraries to make managing the retrieval and the storage of data much easier.
So I guess that's a bit like a Pydantic, right? So if you come from
That's right.
the Python world, Pydantic, you have an equivalent in Julia. So it seems like you're checking off all the boxes of what mainstream Python developers or web developers know, and you're bringing that into the Julia ecosystem. So I have to ask, one of the key things that I think the web frameworks in the Python world struggled a little bit was scaling up, like the synchronous behavior, having multiple connections and scaling up from 1 or 2 users to tens of thousands of users. How does that work with Julia, or Genie, I should say? Genie built on top of Julia. Is there already that kind of infrastructure, or did you have to rethink and build this very carefully and cautiously?
Advantage of using Julia and Genie is that you get scaling out of the box. So Julia really has very good performance, and it has built into the language all the capabilities that allow you to do distributed and parallel computing. So Julia itself makes it very simple to run it across a cluster of computers, for example. It has very good primitives for running asynchronous computing in the language itself. So similar to JavaScript maybe, but like scaling is not an issue with Julia and with Genie applications. And yeah, that's really, I think, one of the strongest selling points of Julia and Genie apps in general.
So my understanding is in the Python ecosystem, when they say asynchronous, that like a round robin waiting, it goes on a queue, and then when something's available, this is being spawned out to process A or process B. In the Julia ecosystem, is the asynchronous behavior, does it work in the same way? Or is it maybe closer to what a high performance computing center would consider synchronous behavior?
The asynchronous story, let's say in Julia, it's quite complex in the sense there are so many ways of doing parallel and distributed and asynchronous computing that I think there's like a dedicated page on how to do that in the documentation. So I think the most important ones are that, we can have asynchronicity in the traditional sense where you have a long running task and you can suspend it and then you continue the execution on the main thread. Your task continues to run in parallel when it gets CPU time, and then you resynchronize and you bring your execution back into the main thread. But also Julia, for instance, out of the box, allows you to run computation on what are called multiple workers, which would be CPU cores. So you can explicitly take a task and say that you want to run this on a separate core. So then it gives you this level of control. And then you can take it even further. And when you, for example, start your application, you can tell it that you want to run it on multiple computers on a cluster. So then, for example, you can repeat this over and over again, and it gives you multiple layers of asynchronicity and parallel computing, depending on what you need.
So this sounds like a super powerful thing, or maybe an underestimated advantage of using Julia. So I'm beginning to understand a little bit more your reasoning to start Genie. But then you started it as an open source package and still is, but then you created a company around this, right? So walk me through, how does a company around this make money if you are giving away the core engine, the core language, the authentication, you're giving the front-end development easy. So how do you make money out of all of this?
Yes, it goes back to the idea of talking to your users and understanding what they need. And after the learnings of having to create steeple and make it easier for Julia users to create web applications, the story didn't stop there. So Julia users wanted more, and they're like, okay, this is still very cool, but maybe can we have something which is even simpler? And is there any way that we can create all these user interfaces and the apps by just simply dragging and dropping components and really helping us become a lot more productive and really boost our development skills? So that's where I thought that would be an interesting opportunity to build a business. Like you have the open core, you have all these open features that allow everybody to build powerful applications that are really not limited by the tech that is available. But yeah, it requires a certain amount of time to develop, and maybe there's a certain learning curve to learn the libraries, the language, that. But if people are willing to pay, then we could have a tool that would make it so much faster for them to develop an app visually. So that was initially just an idea. And I think it came from a discussion at the JuliaCon in 2020 or something like that. And yeah, by a coincidence, I was contacted by somebody at an incubator in Amsterdam called Antler. They asked me if I would be interested to join. So then I proposed this idea of having this no-code app builder for Genie applications. They liked the idea. I was invited to join the incubator. And that's where we started to think of a business plan. Okay, what would the product look like? And then from there, we set up a company and started to build in that direction.
So let me see if I get this straight. So is this kind of on top of all this, the Genie framework, you've got this nice user interface. This is, if I understand it, it's a VS Code plugin that you can drag and drop widgets. And with that, you create your user interface that gets deployed on the web. And that is something that you don't need to type too many lines of code. You say to drag, I don't know, a slider bar, and the sliders associated with this variable, which to a scientific-minded person might be that variable is actually a parameter, which could define or change a simulation. And the simulation, it could be super expensive, intensive, that a Julia programmer could leverage the high-performance computing that they're already used to. And now they're just putting a front end and you just stay within the same language, crossing borders between the mathematical world and the sharing with the rest of the folk. And then you put a price tag on that VS Code plugin, which makes life easy. Is that it?
Yeah, that's right. So the VS Code kind of converts Visual Studio Code into a Julia/Genie IDE that gives a lot of powerful tooling, starting with the UI builder, where you can drag and drop the components and create your application. But also there's other features like a package manager. We want to, it integrates to make deployment of the resulting app very easy. For example, right now we're collaborating with Julia Hub to allow Julia users to deploy their Genie apps on Julia Hub from Visual Studio Code. We're also integrating an AI assistant, which helps with documentation and with code generation. So we're really focusing on making the development experience very easy and fluid and very productive.
So along those lines, there's something interesting you said about the deployment, right? So typically when people think of dashboards, and especially for data scientists, the starting point is one data scientist, one individual has got this idea and insight, would like to share it with others, and doesn't necessarily want to share it with code. And then the idea is you start, okay, can I enable someone to play around with parameters or tweak things and enable others to visualize without looking at the code? But then how do you deploy that? So the deployment, is this something that you pay extra if you deploy it via Genie, or is the strategy to say you're part of the Julia Hub ecosystem and if you deploy via the Julia Hub framework? Or is there also possibility to say, look, I'm not a Julia Hub customer, I have my own Google Cloud infrastructure or Azure or whatnot. Can you walk me through some of my deployment options, or is it all of the above?
It's all of the above in a sense. So the Genie applications can be deployed anywhere. There's really no constraints and there are no limits in regard to that. And again, we have a set of open source packages that people can just install into their apps. And those make it really easy to get you started with that. For instance, there's a package which is called Genie Docker, which if you bring in that the Julia REPL, it makes it really easy to set up a Docker file, which is optimized for your Genie application. And then you can use any of the Docker supporting deployment platforms, which is virtually all of them, to just push your application into production. With Julia Hub, what we wanted was to offer an integrated package where you can go in. They offer a version of Visual Studio Code that runs in the browser. Then there's the Genie plugin also, which is already installed. You develop your application there, you have your compute there, and then you just press a button and you just host it on Julia Hub. But it's not limited to that, and options are varied.
Right, but it's not that. So it's not that you have on Genie Tools your own cloud provider that you charge people to deploy their apps to, or do you also have that as a service?
No, or at least not yet. We worked on that, and it's still work in progress. So we would love to be able to offer this alternative for users in the future, so that they can develop locally on their own computer in Visual Studio Code, and then press a button and just deploy the application on Genie Cloud. But right now, they can either develop locally and then deploy it on any platform of their choice, or develop on Julia Hub and then also deploy there.
So walk me through a little bit of, so you've gone through an open source. I'm assuming this is on GitHub, right? So you've probably started on the GitHub. You have a collaboration going on. But then as you professionalize these things, can you talk a little bit about what are the common tools in further developing Genie? And is this really written in Julia, or is it written in another language and the Julia is the wrapper? Tell me a little bit more about that whole tech stack and the front end. There has to be some CSS. I'm assuming some JavaScript is running somewhere along the lines. Can you walk me through what are my options and what that looks like?
Sure. Yeah, so Genie itself is a native Julia app. Everything is written in Julia, and not only that it's written in Julia, but we put a lot of care to make it a truly Julian experience. Julia, in a sense, is a particular language, or one of the topics that are mostly discussed is, for example, multiple dispatch. So Julia treats data and functions in a way that is not how you would expect if you're coming from a purely object-oriented programming language. So then, Julia has its own quirks and its own look and feel. So then, the idea from the beginning was to make it a framework that feels native to Julia users, and it's something where they feel at home and where everything comes naturally, but also where we leverage the strength of the Julia language in general, how you put things together. And even this idea of having an ecosystem of packages actually builds on the excellent package manager that Julia has, and ability, which is one of these excellent features of the Julia programming language, which allows people to mix and match packages that come from multiple developers, maybe into a coherent ecosystem where all the parts play together very nicely. So then Genie, it's a pure Julia code, which plays very well with all of the Julia ecosystem. We also build on open source Julia packages, for example, the HTTP.jl web server that's part of Genie, and that basically it's the de facto standard for web servers for Julia. We're using GitHub extensively, just as Julia itself does. So, for example, the Julia package manager also relies on GitHub to manage versioning and releases and the whole registry for all of the known packages. And so we really didn't try to reinvent the wheel. We focused on the good parts, and we tried to leverage those as much as we could. And also to reduce the volume of work that we would have to do as maintainers and focus on those things that provide value to the users. So in this mindset, then regarding the full stack, the idea was also to try and leverage as many open source packages as we can, things that are supported, that work well and are efficient and known. For instance, the UIs that are generated by Genie use Vue, and building on top of Vue, our widget library also uses another open source package, which is called Quasar, which is a UI library built for Vue. As for plotting, we use Plotly, and we always try to take very mature, very feature complete packages that are well maintained and documented, and then build around those, incorporate them into our stack, and really just focus on where can we add value for the Julia users to make it really easy for them to leverage the features that are already there.
So you said something interesting there that I want to dive into a little bit deeper. So you said one of the things about Julia is this composability, because it seems like you consciously is saying, okay, let me leverage what exists, the defect standards, the server sides, and some of these things, cross-border languages. But I'm curious, when you call out the composability of Julia being a positive thing, why do you say that as opposed to maybe like the Python ecosystem or other ecosystems that also claim that? Why did you call that out specifically?
Yeah, I think maybe it's cultural particularity of the Julia ecosystem. For instance, I don't know, if you look at Python packages, especially web frameworks, they tend to bundle a lot of features, right? I don't know, if you look at Django, everything is already there out of the box. You get an admin and you get access to the database, you get all the features are already present there. But in Julia, like, the way people think is that you build a small package which provides a very well-defined set of features, and then somebody else can take it and they can extend it, or they can compose it with other packages to improve their API and enhance on top of that. And actually, Genie started in version 1 by incorporating all of the possible features that one could think that are necessary, only to start unbundling them in version 2 and 3 and later on. Yeah, well, first of all, because we came to realize that, okay, not everybody needs authentication. Sometimes we just want to build an API or something that can be public, or not everybody needs to access a database, especially in the Julia world. So why force people to install additional libraries and manage code that they're never going to need? And then, we started to separate all these packages. But also, it's I don't know, the way that Julia applications are architected, the easiest way of providing a plugin ecosystem. You start with a core package and then you add more features on top of that by means of other extra packages which specialize that. So to give you an example, if you want to create this library to interact with the database, right? Then you want to have a package that provides you the core functionality to interact with the database, for example, to generate the queries, to read and write data from a database and so on, maybe migrations to manage the structure of the database. But then you want to have different adapters so that you can use this core library with MySQL, with SQLite, with Postgres, and so on. And this kind of composability is very powerful in the Julia ecosystem. So you can have this kind of core package, which has all the logic, but doesn't connect to any database. And then you just add an additional package, which gives you the adapter to the specific database that you're going to use in your application. And it's been a bit of a journey of discovery, because these design patterns evolved as the language was written itself, starting from version 0 to version 1.10, where it is now. But it's how things have emerged and how Julia apps are being structured now to be efficient and composable.
Because there's an interesting thing that you call out there is the fact that the ecosystem encourages people to build smaller packages and more of them, with the intent of reusing packages at a higher pace than others. But the other thing is, you said it's native Julia, right? So my understanding is many frameworks are not written in core Python itself. So many packages in the Python ecosystem come from different languages. So realistically, when you want an improvement to the language, it's a bit of hit and miss if your package benefits from this, right? But if everything is written in the same language, or native Julia, if the language improves, then the whole ecosystem as a whole evolves at a faster pace. Is that a bit of the philosophy behind this composability that you're also calling out?
Yeah, definitely. So one of the, let's say, points of pride in the Julia ecosystem is that everything is being written in Julia. And actually, one of the reasons why Julia itself came into existence was to solve the so-called two-language problem, right? If you take Python, for instance, there's this joke that Python is like a wrapper around C libraries. Yeah, it's the issue being that you can start prototyping in a highly dynamic, easy to learn programming language like Python. But then when you need performance, when you need to move into production, you usually need to recode some of the parts of your application into something like C. And some of the most famous Python packages are actually just thin wrappers around C libraries that do all the heavy lifting in order to give them good performance. And Julia wanted to solve this problem, wanted to be a language that is both easy to learn, easy to use, highly dynamic, but also give you the performance that you can deploy the same application in production without having to rewrite parts of the app in a high-performance programming language. So then this makes it really easy to read other people's code, to understand what they've done, to contribute to other packages, to develop your own. And a big part of core itself is now written in Julia. So that also makes it very simple for people to see how Julia works on the inside and contribute patches and features to the Julia language itself. And I think this is one of the reasons for Julia's popularity. For example, it was one of the most starred repos on GitHub. It has a lot of contributors. It has a very rich and active community. And this nature of combining one language across the board that is also really easy to read and write.
Playing a little bit the devil's advocate, right? So up until now, you've only told me really good things, right? So it would seem that if everyone agrees with everything you said, then the whole world would be using Julia. So maybe from your opinion, where is it going wrong, or what are the things that are preventing more people from jumping on this idea of using Julia?
So obviously, one of them is that Python is a much older programming language. It has over 30 years of age by now, and it benefits from a very rich package ecosystem. Really, everything that you need already exists in Python. Somebody wrote it, and it's quite simple to reach out, install a package, and get the functionality that you need and create your application. Also, there are a lot of companies that already have existing huge code bases in Python. For them, it would be very difficult to migrate to a new programming language. So you really need to have a very strong incentive, like really Python do, in order to be actually forced to switch to a language when you have a running functional code base. And usually what's causing companies to adopt Julia and move away from Python is this performance issue. For existing code bases, or if you're using packages that are not available in the Julia ecosystem already, you either have to develop them yourself or you have to wait for somebody else to do it. The Julia developers have tried to mitigate these issues, for instance, by adding a bridge between Julia and Python. The creators of the language, the Julia core team, have actually anticipated this problem. And so there's very strong language interop between Julia and Python. Basically, Julia allows one to use Python functions and to use existing Julia code and to call Python libraries from Julia. And there are also packages that allow doing the same thing in reverse. So one can actually use Julia from within Python. However, this is more complicated, and you really need to have a strong reason to do it, because obviously calling Python libraries from Julia will make you not benefit from Julia's performance as it will run at Python speed. And also managing a code base which is written in two languages, it's more complicated than that. So deployments are difficult. You need to manage a Julia version, you need to manage Python version and various packages and so on. So as a result, the option is there. If anybody needs it, they can mix and match the two languages as they. In addition, Julia can call native C, so functions which are written in C. And that's another way of interoperating with other programming languages to extend the language and go beyond the existing libraries. However, the Julia ecosystem has been evolving at a good pace. And now it's quite strong for solving some type of problems, especially, for example, with simulations, with modeling. These are verticals and areas where Julia has become very strong. And we see a lot of researchers and users making Julia their first choice with these categories of apps. However, with others, for example, AI libraries, large language model and all that, Python clearly has taken all the spotlight, and developers that are going towards that area are sticking with Python.
So maybe another part of the question is to try and figure out why or what's preventing Julia from growing based on all the nice things that you've said about it. To the best of my understanding, do companies like Microsoft and support official VS Code plugins? Do they support deployment options? I don't see the coding examples on web frameworks saying Julia. So I see Java, Python, C++, I don't know, maybe Rust, but you don't see Julia. So why is there something inherent evil about the language that you've conveniently left out, or what's the gotcha? There has to be something.
I think it's really just a matter of popularity of the language. So Julia has around 1.5 million users, according to latest stats. And if you compare that to, say, Python, which was probably more than 10 million, it's a much larger user base. Language support, however, it's really good, but it's a community effort. For example, there is a very good Julia plugin for Visual Studio Code, which is community supported. Julia, obviously, it's one of the languages in Jupyter for the notebooks. In addition, we have our own Pluto.jl, which is its own version of reactive notebooks, which are quite powerful and a very good alternative for Jupyter if you're doing Julia alone. So the tooling is there. And actually, there are some big companies which are experimenting with Julia adoption. But I guess, it's not yet officially embraced there at the top here.
No, very good. Especially on your website, I see nice logos and icons, and we'll leave the links in the show notes for people to go and check out who's actually using Genie tools. So I think that's pretty cool, the Genie framework. But maybe also to understand a little bit more. So you're clearly a fan of the open source community, and you called out the community approach of helping build this ecosystem. So I'm assuming you also would benefit from people helping you out. So let's say I would like to investigate Julia. I'm looking for a cool project to work on, and I'm convinced that Genie is the place to be. How could I best help you, and how should I contribute? So when you're looking for new folk, what do you tell them, and what guidelines do you give folk to help you through this process of contributing?
Yeah. So we're very welcoming towards contributors, and we've always been encouraging, and we'd like to see people contributing features and reporting bugs and improving the docs and all that. And again, Julia makes it quite easy by the way and how things are naturally structured, let's say. As I previously mentioned, Julia manages all its package repository openly on GitHub. And really, the easiest way to publish your package is to create a repository on GitHub and then register with the Julia package manager so that it becomes available for installation. The whole infrastructure for creating and managing packages is open, it's visible, it's public repos on GitHub, and everybody can just open, look at the code, interact with the maintainers. And it's the same with Genie. Our packages are all on GitHub, the whole ecosystem. And yeah, we've been lucky to have contributors that come there to report issues, to work on the documentation, to recommend features. If they want to start, I would recommend looking at, for example, at our list of issues. There are quite a few that are still open. And we take the time to tag them, like features, bugs, a good first issue. And we also like to take time from time to time. We organize these sessions with potential contributors. We discuss features, or we even do one-on-ones with users that are interested to develop large parts of the code or applications around Genie libraries. And we try, as well as the rest of the Julia community, to be as welcoming and supportive as we can with contributors and with people that are new to the language or new to web development. We are present everywhere we can. We have a Discord. We have GitHub issues. We have GitHub discussions. So we're everywhere where if people want to interact with us.
So it's not that Genie framework is owned by you as a company. It's owned by you as an individual who's looking for more support and you believe in it. Is that a true statement, or did I misread the situation?
Yeah, definitely. So now Genie framework is put under an organization on GitHub, which has multiple contributors. Some of them are people in the core team, but we've also brought a few contributors that came from outside the initial team and just they were very interested in the project and they made really amazing contributions. Yeah, we consider that they deserve to have a role into directing the project overall. Also, all of the open source packages are licensed under MIT. So that's a very permissive license. People can take the code, they can use it however they want. Also for commercial use, they can modify it in any way. And that's not owned by anybody. It's just the Genie contributors and the Genie maintainers that are in charge of that. While our company, we try to draw a line between, okay, this is open source and the company has nothing to do with that. And this is a commercial product that is used to bring revenue into the company. That's an add-on for people that want to get extra features. And that is also something that is closed source and is not available on a permissive license.
Yeah, that makes sense. So the one thing that we haven't touched upon is testing. Testing numerically in scientific computing languages. So that's a well-known thing. So can you tell me a little bit about how do you test Genie as a web framework? Are there additional tools? Do you do load testing? Can you maybe talk me through a little bit of how do you guarantee things work and can scale so nicely? So you said earlier, you get this for free, but I'm assuming you test this. It's not an empty statement, you get it for free.
Yeah, definitely. So in terms of testing, obviously, we try to have as wide of a possible test suite for the framework itself. I think right now, Genie has over 400 and something tests for the core, and then each individual package has its own testing suite. Julia itself comes with its own testing library, so that included with the language, and it's quite easy to start writing unit tests for your application. We also add a lot of integration tests. So we start the server, we hit the various endpoints, and we test especially the higher level libraries, which are in charge of rendering user interfaces. And yeah, there's also in the ecosystem, there are available some extra packages for improving how you work with tests and for managing, let's say, large test code bases. And we do try to cover as much as possible of the code base with extensive test cases. In addition, because we work on GitHub, it's quite easy to set up continuous integration and to use all sorts of libraries and extensions which are available on GitHub. Benchmarking is really a question that comes up quite a lot. People are really, they want to understand, like, how does it compare with, I don't know, with Rails or with some Python framework and so on. These frameworks are subjective because it's tricky. What kind of features do you test and in what context? It's difficult to really compare the exact same type of code. But we did run Genie through some of these benchmarks. And what we see, for example, is that we consistently get much better performance than frameworks like Django or Ruby on Rails and so on. And that comes like natively out of the box. However, benchmarking is a bit more difficult with Julia applications because of a thing which is called time to first X in the Julia ecosystem. It started as like time to first plot. For a web app would be like some time to first page rendering. It's basically the idea that Julia is a programming language which is just in time compiled. You write your code, and when you run a certain function, that function gets compiled on the fly when it is being accessed for the first time. And this is a bit of a problematic issue, for example, with Julia application, in the sense that they have a longer startup time. So for this reason, Julia is really efficient for applications that are running for a long time, like web apps, for instance. If you have it running for days and so on, once it starts, and it's really fast. But if you want to create something that runs a small function and then exits, or it's some kind of Lambda deployment, because of this added compilation time, there's an initial delay for handling the first request. And it's called time to first plot because this issue popped up in the ecosystem where people were plotting things. And the first time we were plotting something, it would take very long. The community has worked a lot to shorten the time to first plot with every Julia release. And now it's getting better and better by basically pre-compiling all these packages when you install them to make sure that just-in-time compilation is being eliminated. But then, yeah, Genie as the Julia app is also impacted by this. So time to first rendering, when you first render a page for the first time, that can be a bit slower because Julia compiler needs to compile the code when it's being called for the first time. So benchmarking for Julia is a bit difficult. You need to take into account this initial compilation time. But then once the code is compiled, then serving the pages is really performant. As for running the applications in production, that's pretty standard, like with Python or Ruby or JavaScript app. You just start your application on the server, and then indeed you would use something like Nginx as a proxy, and there's a web server in front of it to serve the assets and run that on port 80 and proxy the request between the web server and the web app.
Adrian, so if people want to get in contact or in touch with you and want to contribute, what is the best way to do so?
I think the best way would be to go to genieframework.com. There we have all the information. We have links to the documentation, to the demo apps. Maybe they want to take a look and see what's being built with Genie. They can look at the code for the demo application, see what it feels like, what it looks like, run it on their own. And then we're available on GitHub. We're available on Discord. Both the links are on our website. And we're always very happy to hear from users if they have questions or if they want to build, if they want to contribute, or whatever help or questions they might have.
Very cool. And maybe so there's a bonus question, right? So what's coming up next on Genie?
Yeah, actually, we have a pretty long roadmap ahead, and we're full of ideas. I would say that some of the features that are quite high on roadmap are in regards to enterprise features. We've been getting a lot of requests to bring some missing enterprise features into the Genie ecosystem. For instance, authentication story probably needs more work. Maybe adding things like multi-factor and just overall boosting our authentication package, which could use more features to serve the enterprise users. Another very common request in terms of user interfaces, especially again from enterprise users, is the ability to bring on their own custom components. And we think that this is actually going to make Julia adoption easier because a lot of companies already have their own code base, they have their own components, their UIs. So we want to make it really easy for them to integrate with whatever code bases they have and be able to bring their own UI and components in. The same goes about theming. For instance, lots of companies have style guides that they need to implement, and we want to work on that as well. And yeah, as a bonus, of course, we want to add more and more AI features to make things easier for our users. And we have some interesting ideas in our mind to try to use AI for code generation and to help users generate end-to-end applications. And we had some really interesting prototypes so far. You can just go into a Genie Builder, give it the prompt with the description of the app that you want to create, and get a full UI. And this is really promising. Like, it can put a plot, you can put sliders and drop downs. And yeah, maybe we can eliminate all of the coding parts and just let people describe the app that they want and have the AI build it with Genie, debug it, deploy it. And yeah, we're really focusing on making the experience as easy as possible for the users to build what they need.
This is a great place to stop this episode. I hope it triggered your curiosity in some shape or form of how MATLAB, Python, and Julia are actually used in the real world. If you did find it interesting, just subscribe in your favorite podcast player. And while you're at it, write a review, as this will help the podcast growing strong. In addition to that, don't be shy, share it with a couple of friends, as who knows, one of them might be a future guest on Inspiring Computing. Thank you.